So welcome to today's talk. We're very fortunate to have Dr. Jeremy Freese from Stanford University join us and speak to us today about transparency and reproducibility, doing open quantitative social science. Before we get going into the speech, I would like to give honor and thanks to the Haudenosaunee and the Anishinaabe nations, who are the traditional inhabitants of the land where McMaster University now stands. And to say that is to acknowledge a debt to those who were here before us and to recognize our responsibility as guests here to respect and honor the intimate relationship that Indigenous peoples have to this land. Jeremy Freese, our guest today, he is professor and chair of the Department of Sociology at Stanford University. Jeremy specializes in improving the practice and the conceptualization of social research, particularly quantitative methods. He's co-PI of three major social science projects that are considered public goods, the General Social Survey being one of the best known ones, the Wisconsin Longitudinal Study, and also the time-sharing experiments in the social sciences. Jeremy leads research regarding the rise of meta-analysis and open science, and he's co-author of the 2019 book, Transparent and Reproducible Social Science Research, as well as other research journal articles on this topic. So in his work, Jeremy highlights the importance of transparency, openness, and reproducibility in research, especially when we think about the real-life impacts that social science research can have through public policy, health, and other venues. So it's really our pleasure today, Jeremy, to have you here and to learn from you. So over to you.
Great. Thank you very much. I'm excited to be here today. I'm sorry I'm a little bit dressed down, but you have to remember this is California, and so I'm working a little bit earlier than usual, and I realized as I was getting ready for this that changing into better clothes would involve me waking my wife up, and I decided I'd rather apologize to y'all than apologize to her. Okay, so I'm excited to be here. You can see on my first slide, I refer to some of the great collaborators I've had for different things that I've done on the topic of open science. But what I, okay, there we go. So when I talk about open science is, pun intended, an umbrella term for a number of different things that are going on in science as a movement. The things I'm going to talk about today are mostly surround transparency and reproducibility and open data and open materials, open code, that kinds of things. And I'm going to talk less about open source tools and open access publishing. But open is the key watchword, I think, that brings together a number of different initiatives, which all stem from some things. And particularly, being a sociologist, one of the things I want to talk about is actually that you can think about a lot of things going on. If you think about open science as being a movement, you can think about various developments in that movement in at least somewhat sociological terms, in terms of trying to understand why it's going on and why now one is hearing so much about it, or why in the last decade one heard so much more about it than in previous time. So just to talk about what I'm going to talk about here. So first, I'm going to talk about some of the sociological underpinnings of the movement, and then I'm going to talk about some of the actual initiatives that have been developed to try to address the core problems. So I'm going to set up what I think the core problems of the open science movement are, at least those that lead to issues around reproducibility and transparency. And then I'm going to talk about initiatives connected to those. And then I'm going to talk about some of the really specific, almost pathologically specific for a talk like this, nuts and bolts about workflow organization for a project and coding. But to start, I think that if you look at all this from the perspective of sociology, and one of the areas of sociology, even though it's not my own, is the study of social movements, you can see a lot of things in open science as being really very routine in what one sees in what are called reform social movements. Sometimes people will talk about open science as being a revolution. I don't really see this in revolutionary terms, but I see it more in what social movements that are associated with reform. What do I mean by that? I mean that one sees, for example, when people motivate it, they'll often motivate it by means of drawing visions about how a more idealized or better past has been corrupted in more recent times, and trying to return to aspects of at least an idealized past. I think that you can see that there are long-run developments that come into a collision with one another, kind of create an increasing tension, and then they sort of break, and that breaking point usually surrounds some precipitating events. So if you're familiar at all with reform social movements, many examples, they often have features of this form. What do I mean by a motivating vision? By that, so as was mentioned in my kind introduction, I have this book from the UC Press on transparent and reproducible social science research. And the other two authors on that, Garrett Christensen and Ted Miguel, are economists. And when we were talking about how to organize the book, they said, you know what, we would really like to kind of start with as a motivating vision of the book is we'd like to start with Robert Merton. And I even had to check with them that they were talking about sociology's Robert Merton rather than Robert Merton's son, also named Robert Merton, economist, won the Nobel Prize. But this is Robert Merton, who at one time was the most prominent American sociologist, but his reputation has come into eclipse in a lot of ways, but he's had this reemergence in the open science movement as kind of a hero for that. And that's because of Merton's movement, Merton's writing about norms of science. And so in 1942, during World War II, Merton wrote a famous essay. And from Merton's perspective, what Merton was doing was he looked at science as something that worked. And at that time, of course, you could unquestionably, science was, where we were not far off the development of antibiotics, medicine, medical science starting to save far more lives than it had in the past. 20 years from the development of discovery and synthesization of insulin. You have the developments in quantum physics that in just a few years were going to lead to the atom bomb. But you look around and you see all of these accomplishments of science. And so Merton saw science as a highly functioning social institution and then thought, well, why? And he said it was because that scientists have an ethos, and that ethos involves norms, and then tried to articulate what those norms were. And two of them were the idea of what he called communism, but people since call communalism because of the stigma of communism, but that scientific goods are ultimately public goods, and that they promote collective collaboration, that science is ultimately a community. And then also this idea of a community that has organized skepticism, right? That scientific claims needed to be exposed to critical scrutiny, and that scientists were subject to, he said, a rigorous policing in a way that's perhaps unparalleled in any other field of activity. And I think in terms of then thinking about this as kind of an idyllic past, open science movement people look at these norms and have seen a world where science in many ways has fallen away from those norms, right? That there's not the same collective collaboration, and particularly this failure of organized skepticism in terms of the degree to which claims even are available for critical scrutiny, right? And so that's kind of the idealized past. But then if we think about the collision of different developments, I think in one respect, you see how long-standing practices came into conflict with revolution in information technology, right? I'm not going to talk very much about open science publishing, but of course that is one key example, right? So journals have a long history where the history of journals was providing a way for people to get their work seen by other people. Journals were the only means for doing so, and effectively a collective enterprise for distributing work, making work available. But technology has instead created all these other ways of making work available, so that in effect, a lot of legacy and paywall publishers, a lot of their technology interface is actually restricting access to work. They make it available, but they make it available only to subscribers and have to keep sort of other subscribers from seeing work and doing all kinds of practices for that. Or with data dissemination, there was the idea that that data would be something that would be very hard to distribute to other people. It would involve a lot of labor and cost to make your data available for other people, and so people didn't share data so much. But now with information technology, those arguments that are somehow very difficult to share data don't hold in quite the same way. And then also there's different ideas about scientists and other stakeholders. Again, in open access publishing, you see the rise of the idea that instead of having an idea of thinking about scientists as this closed community that is a relatively small set of people, that you have the need for the idea that citizens should have a right to be able to see scientific papers to inform themselves, citizens looking at data, wanting to have things available to them. And then in terms of a precipitating event, there was a rush of things that happened in the circa between 2011 and 2015 specifically, seemingly all over social science. There were different kinds of concerns about there being a credibility crisis in scientific research, right? And so in psychology, even though there were these widely publicized episodes of fraud, Dedrick Stoppel in the Netherlands being the most familiar, a radicalizing episode, if you look at accounts of psychologists in social psychology, in some ways was a ground zero, was this publication of a paper by Daryl Bem on precognition, where Daryl Bem published a paper in a very prominent social psychology journal, probably the leading field journal for social psychology, finding evidence in favor of precognition. That is the idea that people's behavior was influenced by something that was going to subsequently happen to them. And the issue with this, it's more interesting if you think that precognition is not real than if you think that precognition is real. Because if you think precognition is not real, the issue is that the study was doing all of the things that all kinds of other experiments were doing, in many ways looked particularly rigorous for a social psychology experiment, and yet was reaching a conclusion that seemed impossible. So what does that say about existing methodology if somebody is doing all of the things that get somebody into print, sailing well above the bar to that in some extent, and yet producing an impossible conclusion? Moreover, there was a kicker with this where the journal that published the Bem paper soon thereafter received a paper that tried to replicate Bem studies and did not find evidence surprisingly, did not find evidence that people have psychic abilities. And that same journal desk rejected that paper on the grounds that they didn't publish replications. So they would publish novel research, but they wouldn't publish replications. And if you think about that, if you take as an article of faith the idea that science is supposed to be self-correcting, how can a science be self-correcting if you can't actually publish things that call original findings into account? So that was a source of all kinds of a crisis. And in social psychology, I mean, it's this book, Thinking Fast and Slow. I don't know if it was as big in Canada as it was in the United States, but it was one of the biggest trade books of that time in the United States. And it was describing its findings in these terms, with this striking quote about how, like, you have no choice but to accept that the major conclusions of these studies are true. And yet, in a short space of time, the very studies that this quote is talking about, so-called, I guess I think of them as metaphorical priming, but priming effect studies, a large swath of these came into doubt because of failing replication attempts. And so just this traumatic, almost for the field, inversion of its ideas of what it knew as a field. And alongside this, in political science, you had a scandal where for the year 2014, what was probably the most publicized poli-sci study was then shown to be the result of completely fraudulent data. You had in economics the issue where some data that had been used to make claims about audacity had turned out to have a spreadsheet error. You had a number of different things in social science provoking a crisis of confidence of one kind or another. And if we look at the root kind of causes of this, I think you see a juxtaposition of three things. I think one, you see that there are incentives that authors have to find some results versus others. Though that can be politically appealing results in some social science. In social psychologists, people will often say just the idea is counterintuitive results that are going to be striking, results that are going to get a lot of attention. And so investigators have incentives to find those results. Now, that by itself would not be an issue, but the issue is when you have that kind of strong incentive to find results, and then you have a lot of flexibility in the ability of researchers to produce evidence for those choices, consciously or unconsciously be biased, but you have relatively weak evidentiary safeguards for whether or not a researcher can produce findings for their desired conclusion. And then furthering this, if you have a weak capacity for work to be reassessed after publication. So you have strong incentives to find a particular thing. You have relatively weak safeguards so people can produce evidence for that thing. And then after they find evidence for that thing, you have a weak ability of a field to actually assess that or ever correct itself or bring that into doubt. You put those all together and you can see where a credibility crisis might come from, right? And so again, to get at these kind of core problems that I take initiatives as trying to solve, I would think that you have this idea of you having practices out of step with technological and other social developments, and you have practices that are increasingly understood as undermining science as a trustworthy and self-correcting enterprise. Right? And this is where I think a lot of calls in the last decade for increased transparency and emphasis on reproducibility have come from. The analogy I like to use for it is the idea of an open kitchen, right? If you have, we're all familiar with the idea of certain people who have worked in the back of a closed kitchen restaurant and won't eat at that restaurant because they say, well, if you know how it gets made, it's not trustworthy stuff, right? And one of the ideas of the open kitchen movement, in addition to being aesthetic in some ways, is the idea that you don't have to have trust in what's going on in the kitchen because you can see it right there for yourself. You can see the process. It's not only kind of entertaining to watch, but it provides this confidence in what is going on. And a lot of transparency initiatives do the same thing, where they make what was formerly the backstage of science available for people to see and to inspect for themselves if they so choose. And so a first part of that idea of transparency is just offering, disclosing, making clear different things that are going on. And from here, health research has a strong tradition of very formal guidelines for different things in terms of what they're supposed to report, rather than being able to be kind of flexible and squishy and maybe not report things that are less convenient for what it is you're doing, being very explicit about what is supposed to be disclosed in research. And there are examples of this in social science that have come about, both in terms of what to report about experiments and then what specific things to report about surveys from APOR. The APOR guidelines are great. The issue is probably more that they're not as respected, or they're not as widely used as they should be or known about. In my own field, sociology, people will do all kinds of wild stuff, what they call a response rate. APOR provides very rigorous definitions of what a response rate ought to be for a survey. And then a different aspect is to try to restore, in one way or another, trust in prediction and confirmatory research. I have sheep up here because Pasteur, in developing his anthrax vaccine, he was able to, he convened a bunch of luminaries in France to witness the experiment, to see him expose some sheep, there were other animals too, but the sheep were among them, to the anthrax virus, and other sheep not. And predict at the time that, look, these sheep that he exposed them all to the virus, and he inoculated some and didn't inoculate the others. And he said that these sheep that I didn't inoculate, they're going to die, and the sheep that I inoculated are going to live. And then those same luminaries came back 24 hours, 40, whatever, however long later. And in fact, that was what happened. With the sheep, it was all the case. All those sheep died that got anthrax. And what makes that a good example in my mind is those luminaries even signed documents with the paper showing that they witnessed this. There was this idea that Pasteur had made a prediction and he said what was going to happen, and those luminaries were there to verify that what he predicted happened. And as a result of him making a prediction, we might have more confidence in what he's saying being true. This idea that if you can predict something and then it happens, that's true. But of course, in a lot of social science, papers are structured around the idea of making predictions, but nobody ever saw that prediction until after the findings were produced and when they see a draft of the paper, and then the paper shows that all of these predictions are borne out, but you don't know chronologically when those predictions in fact happened, right? And you don't have luminaries around you to sign about predicting, but instead we can use technology, and technology is even better than having luminaries, because what you can do is you can pre-register your study, and this has become, of course, very common in psychology, and is rising also in other fields, which is that when you pre-register a study, practice that started in clinical trials in medicine, you express your predictions and how you're going to analyze the data in advance, and then you can demonstrate that the hypotheses you had beforehand and the analytic decisions you made, that you in fact had those predictions and you didn't just analyze your data in a way that bore those predictions, that was going to bear those predictions out, right? And there's lots of templates and repositories in order to do that. I would recommend using the Open Science framework. You can just Google Open Science pre-registration. It'll take you right there as the first link. And so that's a way of being able to restore faith in predictive practices. Of course, like all of these initiatives, it is not perfect as a method of doing it. One issue is that studies will pre-register, but then not do what they said they were going to do, and they don't tell. It's fine if they tell you that they had to deviate for some reason, but if they don't do what they said they were going to do and don't disclose this, that can be a problem. Often plans are underspecified, sometimes dramatically underspecified, where they don't really indicate, they pre-register the hypotheses, but they don't really explain how they're going to analyze the data. And so they still have a lot of flexibility in terms of being able to torture the data until it tells them exactly what they want to hear. And then it's also a problem for those of us who do a lot of our work with existing data. There's not a great, I think, solution for pre-registration for existing data, but that's fine. Not every innovation is going to be able to work for every method. But this is, I think, an important thing for experimental social science. And a different aspect of trying to improve self-correction is different ways of trying to promote the verifiability and repeatability of findings. Sometimes this goes under the heading of replication, but replication is replication's a funny word in social science, because when economists say the word replication and when psychologists say the word replication, what they're probably talking about is not the same thing. Although the economists have kind of changed their meaning a little bit more to psychologists, but the big difference is whether somebody's talking about replication as meaning being able to gather new data that finds the same thing as what somebody found with older data. We might call that repeatability of findings, versus being able to show that another person can take the same data and reach the same conclusion from that data, which is the most common thing that economists mean when they talk about replication. And that I refer to more as the verifiability of finding. And so self-correction involves both the idea of being able to verify findings and to be able to show that findings can be repeated in new data. And so if we think about different efforts to that, if we think about a cornerstone for verifiability, there's this not any possibility of verifiability if there's not the possibility of data being made available to others, right? And so data sharing is beneficial because it increases the rate in which findings can be learned from a data collection project. Even if one investigator or investigative team would eventually get around to all 20 cool things that can be done with data, if that data is shared, those 20 things will get done faster if they're great ideas. It also allows the possibility of independently verifying findings. That's the thing that's most important from the standpoint of the self-correction of science, perhaps. And it also allows the idea that other people who have different ideas than the investigator can use that data to extend findings in ways that the original authors didn't anticipate. So in terms of thinking about what we talked about at the beginning with communalism and the Mertonian idea of that, data sharing is kind of a no-brainer that allowing data to be public, as long as the original people who collect the data are appropriately credited, makes a lot of sense in terms of its collective benefits, right? Incidentally, I'm involved with the General Social Survey. Long before I became involved with the General Social Survey got its first respondent the same year I was born. The General Social Survey, even from its beginning, made data available to everyone. And I think that's one of the, at that time, it was extremely unusual. And I take great pride in that, being involved in the project, that it was so early to that party of making its data available to everyone. If you want to share data, there's a lot of different options in social science. For most of my own purposes, I use the Open Science Framework. If you need a more curated option, Open ICPSR is good. Dataverse is more used by political scientists, but is perfectly fine and quite good. Zenodo is nice for larger applications. It's run by the people in Switzerland who do the Hadron Collider and such, do Zenodo. And Figshare is a popular option for data scientists. So you have a lot of different options for sharing data that each offer its own wrinkles for how to do it. And then the other part of this is to have different kinds of policies that require data and code sharing as a condition for publication. So prior to this, and still to the case for the vast majority of my own field of sociology, there's not any kind of stipulation when you publish a paper that your data or code are available. You don't even have to say whether your data or code are going to be available. You can leave it a great mystery whether or not anybody else can see the data or code for your paper. A journal that I'm involved with, Sociological Science, is about to be the first English language sociology journal, straight sociology journal, I think, that is going to have a contemporary data sharing policy. But why do you need a policy about stipulating things with publication? Because if your policy is just that authors will do this upon request after publication, if you make it that kind of post-publication matter, there's all kinds of evidence from people who have tried to study this, who have asked authors to make data available in a systematic way, that people don't do this. And so, yeah, the compliance with this is just very low, right? And so instead, there's guidelines. The strongest guidelines in social science are by economists. This is an example of the American Economic Association journals. But even for the American Economic Association journals, it should be understood that they recognize that not all data can be shared. About a third of data published in the American Economic Review, for example, has proprietary data that can't be shared. It's not the case that people think that you can't learn useful things from data that can't be shared. But it should be recognized, it should be certainly disclosed that you can't share that data, and it's something that can be assessed about findings. Economists have also figured out some very intriguing ways of trying to still allow findings to be verified even when the data can't be shared. But in terms of objections that people have to these sorts of policies, the biggest one is people will say, we can't have a policy because not all data can be shared. But people recognize this, and the idea that there needs to be some kind of exemption is well established. There can also be embargoes if there's that strong a worry about the idea that somebody's going to be too immediately scooped if data are made to be immediately available. And it is the case that people worry, like, I went to all this work collecting data, now I'm making it available. Other people who didn't do all that work, they can get publications. And that suggests that there needs to be strong practices of data citation and giving people credit and recognizing credit for collecting data. But that's not a good reason to just keep data private and keep it unable for anybody to see it. Okay, so then let me talk a little bit about practices of reproducible analyses, but I also provide a little QR code here for a website that I've got a little bit in progress where I'm trying to also provide some key principles from code. And if you missed the QR code here, I put it up a couple of other times as this goes on. If you want to see that. But just here, I'm just going to talk very nuts and bolts. If you do quantitative social science where you're analyzing data, for doing that analysis in a way that's reproducible. But the big overarching principle for it is even if you are a research sociopath who has no interest in collective benefits from your work, there's still a lot of selfish benefit to being very reproducible in the way that you do practice. Because a lot of the things that help for reproducibility are ways of making your code more accessible to other people so that other people can understand what you're doing. But it turns out that when you make work that is easier for other people to understand what you're doing, that has a very that has ways that it ends up also being very useful for oneself, one's future self, because it's very easy if you have projects that gestate over a long period. In sociology, you almost certainly do, because even if you do all the work all at once, then you get back reviewers' comments on the paper, and they want changes to the analysis to be made. And so you have to be able to go back and understand what you did. It has ways of being useful for yourself in the future. Future you thanks you for it. And it's one of the reasons that I'm very skeptical when people say that doing things the reproducible way takes more time, because I do think that there are things that take more time in the very immediate term, that is to say in one work session. But I think I more than make up for that in terms of how easy it is for me when I have to go back to a project to get myself up to speed, whereas I see other people struggle to figure out what they did because their code and things are held together with string and gum and other stuff. Okay, so the biggest sort of general principle is, if you like crime, police procedurals, law and order type things, there's the idea of a chain of custody. And I think that same thing applies to code, where you want projects to have a chain of code that goes all the way from the raw data, the data that comes to you from a world. If you collect surveys, it comes to you from your survey vendor. Or if you collect experiments that way, that came to you as raw data, to every result that's provided in a paper. You want that to be a very clean chain of code that you can get all the way from one to the other, right? And so for that, I think the first path to that, or the first way to get that, is to use a very clear folder structure. What do I mean by that? Here's where I get into just being very like, this is how I do it. This is how I do it in Stata, for example, is I always use the same structure of folders. I have a folder where I keep my code files. I always call that do in Stata. I always have a folder with my raw data. I always call that raw. I always have a folder. I call it DTA, but you can call it other things. But I would recommend whatever you do, calling it that same way every time. And so then you never have to wonder how it is that you did it. And also you can even create for yourself a little template. When you just start a project, you just make these folders and you're good to go. And then everything will work because you'll know where everything is. And everything will work especially well if you have what you can call, what sometimes is called a master script file. I know somebody, a sociologist, who calls this a run all, because it's the thing that will run all of your work. I kind of like it. It kind of has a ring to it. But you basically have one code file. You don't have one code file overall once your project gets to any complexity. But instead, you have one code file that will call each and every code file in your analysis. And that's the thing that will ultimately reproduce your whole chain of custody, your whole chain of code. You just run that one code file and it will. So basically that code file is then a series of instructions to run other code files, if that makes sense. But it's got your whole project right there. So, so I think that is super handy. I will often call it something like overall project workflow. That's probably more of a complicated name than it needs to be. But if you give that, first of all, if you always give it the same name, you can find it easily. If you use a special character like an underscore to start the file name, then it will put it at the top of your file list, for example, and you can find it more easily. But one way or another, always have that piece of code that you can rely on that's going to call everything. So this is from one project where I did where that one do file called all of these other do files from the project and then some, right? And so then it ends up looking something like this, where it just gives the individual instructions, and the master script file itself is just a series. Instead of do is the thing that runs other do files, it will just run those code files for you. But to make all this work, I strongly encourage the use of relative paths. This is magic, if you can get that to work, which is that what you don't want to do in code is you don't want to have something where you have some big path name like that, users, Jeremy Freese, Dropbox, whatever. But instead, you just want to have something where you're able to say, go up a file folder, looking for it in the DTA folder and look for the file there, right? So the difference with a relative path is a relative path doesn't have the details of the structure of your hard drive on it. Why is this a good thing? Because then you can give the folder to another person, and as long as they do the one thing I'm going to mention next, it will just work, right? And the thing that you have to do to make this just work is you have to have a convention for what your working directory will be, right? So you can set in Stata, in R or something, you can set a directory to be the directory from which everything follows, the directory from which it will understand that dot means go up a folder from there and then down into the DTA folder. And what will make that easy for your life is if that is always the working folder. You always write your code like the working folder is the folder that do file sits in, or that code file sits in. So in other words, if you've got a code file, you are always writing your code as if your working directory is that same directory. All right, it's even easier because you can just say, set your session to the source file location, and it will always do that for you. Okay. Right? So you can just no code changes then are needed. You need to use some kind of system for version control. This is this is counter to so something that people will do with when they're writing documents, and this works perfectly well for writing documents. We've all done this, where when you have a new version of a file, you give it a name, and maybe you put the date, maybe you put your initials, you have the file name and then like your date, the initials, maybe you put aspirationally things like final or something, all in that file name, and it gets longer and longer. In other words, you give the updated, a new version of a file, the new name. And that works fine for documents. That will never cause you a problem for documents so much. For code, it's disastrous. For code, when you do it, that causes a problem, because then it breaks all of your code, because your code is because I just told you to have do files that call other do files. So you don't want to change your name of a do file that way, but you still might want to keep versions. You want to be able to say like, okay, well, I'm going to try something out here and maybe it won't work, and I want to be able to go back to my old version. This is the magic that will allow you to do this without having, you can use things like GitHub if you know what I'm talking about with GitHub, but this is if you don't want to use GitHub. What can you do? What you can do is change the old version of the file's name rather than the new one. So if you've got a simple name for a file and you want to fork it so that you have an old version you can go back to, give the simple name, keep the simple name for your new version of the file, change the old version's name of the file. You do that, and if you ever want to go back to that old version, just go back and change its name to the current name and it will still work. But otherwise, everything will still work. And so that's powerful magic when you get the hang of it, and works very well. Okay, so I'm getting to where I should get to the Q&A time. So I'm going to skip the other details of this, but I've got, like I said, I've got the QR code with different sorts of ideas for this. But let me talk about one thing that I have become to think is increasingly important with code writing is that there's a Goldilocks aspect to documenting your code. That is to say that the biggest problem people will have documenting their code is they won't document it enough. And so then they go back and they can't figure out what they did. But an increasingly painful or increasing thing that I see that is also painful because it's the more conscientious person who does this is people who over document their code. That is to say they put so many things in their code that it actually makes the documentation harder to follow, because the more things you document, the less likely any one thing you document in your code is going to be read. I think the most important, and it's kind of then something to try to figure out what's important to document. I do think the most important piece of documentation in a code file is what is at the very top, especially if you, as I think you should, break your files up into different code files for different tasks. And so I think of it as a mission statement, but at the top of my code, I always try to say like, okay, what's this file do, right? And then what does it need to take as its input in order to work properly? And what does it generate as its output? And then I try to think, if I were going to add a fourth point to this, anything that somebody looking at this or my future self might need to know or might think incorrectly about if they were just looking at those first three things in order to know what's going on. So I think the most important thing is at the top there. And if I follow all of the top, then at least I know that if I don't follow something below, I could redo it and I would understand what it needed to do. Of course, that's not optimal, but I do think that's the most important, is what you put at the top. And so I give an example of that here, but I do think that's important. And the other part of documentation that I think is important to help you not document your code excessively is to self-document as much as possible. What do I mean by self-document? I mean, give variables names that themselves explain what the variable is. So a lot of data comes to you where it'll have a variable that the name is like V3001. And you might even be able to yourself remember, especially if you're younger, remember what V3001 means. But if you can give that, and if it's level of education, if you just take the one line of code to rename that to education, your future self will thank you. Okay, so I have other tips like that that's on the website that I put up as a QR code, but otherwise I am happy to take any questions. And I'll put the QR code up there too. So do we have any questions? And in the chat, Grant notes that there's, it's even got an Aurora name to it. That's great. A national dataverse that's called Borealis. And I assume, that, Grant, that then you mean it runs out of the Borealis, it runs off of Dataverse. It's an example of a Dataverse. Yeah, so that's great. And that's one of the nice things about Dataverse is instead of being centrally housed, it's more like a set of specifications that you can use so you can host your own Dataverse. Or organizations can host Dataverses as well.
I had a question, Jeremy.
Sure.
You were mentioning that, a lot of social scientists don't necessarily follow good reporting guidelines that are out there, like the AAPORs.
Yeah.
So how do we, incentivize, or what do we do to get researchers to start following, these better reporting guidelines?
No, and I think that's a great question. So I think first of all, I think that they're that published standards are good when they exist. So political science has had a published standard for experiments. I think that's very useful. It's very useful because it takes implicit ideas about what one should do, and it makes them explicit in a way that somebody can refer to. So there's something that people can all refer to and know, and they can say that I followed this specific and explicit reporting guideline. And then after that, I think it's up to reviewers. But without a standard, reviewers just have to be, and of course they are kind of ad hoc and have to say, oh, this should really report the number of respondents, or you say this is a response rate, but what kind of response rate is this? That sort of thing. And so it's ultimately reviewers are the people that need to ask for that. But it's great when they can refer to a published standard. Oh, Lars is here. Hey, oh, that's great, Lars. I didn't know you were here.
Didn't want to miss it.
Great. Sorry, Lars, I didn't do GitHub enough, but this is a version for people who are not yet at the GitHub level.
And that's necessary too.
Yeah.
Baby steps.
Baby steps. Well, these are full-on toddler steps, but sure, yes.
For some, these are giant toddler steps.
Yeah.
Do we have any other questions for Jeremy? Otherwise, actually, I have another question as well.
Sure.
Speaking to, a lot of governments are having open data initiatives.
Yeah.
And I'm wondering, what are best practices or any concerns about, having, data out there for people who are not necessarily, given the tools to analyze it properly or the experience?
Well, in a lot of ways with open data, I'm probably less concerned about people who don't have the tools to analyze it properly than I am about people who full well have the tools but have malignant purposes in mind for using the data. So for people who don't have the tools, one of the heartening developments, I don't know if it's the same in Canada. In the United States, data science is all over campuses now as a rising major, and as a result of all of this, literacy and ability to work with data by folks who are not professional data analysts is not a trivial thing anymore. There are people out there. I'm not saying random person or even random college graduate has good facility to analyze data, but people who are not social scientists as a job still have a lot of ability to kind of analyze, especially rectangular data. And so, yeah, you never know. I mean, we with the General Social Survey, we have a lot of journalist uses, and we've done things to make it easier for journalists to use the data. But they also increasingly have, if not their own data competency, people who are among their kind of contacts and folks who help them out, who have a lot of facility with data. I think that issues around potential bad actors for confidential data can be pretty dramatic. One of the things that can make it dramatic is it can be very hard to tell what sorts of data that you have in conjunction with other data can make somebody identifiable. So you can recognize that in your data, there's not something that would make somebody identifiable. But when you start to imagine how multiple data sets or data sets with public records, especially since so many public records become online, how that might be able to be something that can be harnessed to make someone identifiable. And so that's the big issue. I still think even in some ways with that, there's a bit that's a little bit misleading, because like with the General Social Survey, what we worry about a lot in terms of identifiability is whether somebody out there in the world could tell who respondent 735 is, right? Or is there some way to figure that out from the information that's in our data set? And while that, I'm not saying that that's not important, I think the actual thing that is the more alarming use case that doesn't get as much attention and is actually kind of scary to think about. And you know, I even kind of am reluctant to bring it up because it works it doesn't work to my interest to bring this up, but like people who know somebody else is in a survey and have some facility with data. If you know somebody is in a survey, you have a lot of leverage to try to figure out who that person is, right? So in other words, if you knew that your spouse was in the general social survey and you've got good facility with data, could you figure out who your spouse is? And then you might have an actual interest in like what what it is that they said in response to particular questions. That I think is a much more concerning kind of data security problem in terms of thinking about real uses. And there are not great answers for that in terms of current data disclosure procedures.
We have a question in the chat about how this might apply to qualitative data, if you're able to speak to that.
Yeah, so I have, so it's great that there have been initiatives to figure out what to do with qualitative data. I have been reluctant to weigh in on that just because although I have qualitative projects with qualitative collaborators, I'm not working with that data in the same way I work with quantitative data. And I kind of feel like methodological communities need to figure out their own standards. But I do think that with qualitative data, one of the reasons I feel strongly about this is that I think quantitative researchers can be incredibly naive about, if we're talking about things like qualitative interview data, about the confidentiality risks in that data. Because the big thing about qualitative interview data, if that data comes out of some community of people for whom the researcher is, anyway, if it comes out of a community for people, it's very hard for a researcher. A researcher can't just take out names and that data is not identifiable. And they can't even I think it's very hard for qualitative researchers with interview data to know what would be identifiable to other people in that community if they had access to it. So I think in terms of the idea of telling qualitative researchers they can just put their they can just take out names and put their interview transcripts online, I think that's very reluctant. I do think that there are better solutions than what's currently being done, probably surrounding the idea though of like different kinds of like licensure type use where it's like you're not going to put it online, but a qualified investigator can obtain it through an archive. And so then you can screen out the idea that somebody who has an interest in trying to identify other people in that same community could flip through transcripts and see who somebody is. But you even have examples, there are anecdotal examples in qualitative research where somebody put something in a book or they put something in an article, quotes from a respondent that they thought were anonymous, but people from that community who read the book or whatever, they knew who they were talking about in ways that the interviewer would have rather that had been confidential.
Well, thank you very much, Jeremy. There's a couple of comments here just about qualitative data repository at Syracuse, and then a databrary at NYU, and then FRDR working on a zero knowledge encryption system. So do take a look at the chat. Our time is up. So I do want to say a huge thanks to you, Jeremy, for what a fascinating talk. And everyone here, thank you for joining us today. In the chat, you will see that there is a very simple 1-minute feedback survey that asks you for your feedback and also can help us plan for future speakers. And you can give your feedback at the link there. If you do have any further questions, our email address is talk.to.spark@mcmaster.ca. Thank you so much. If you are on McMaster University campus, you are welcome to come to our office for pizza today and every Friday after the Spark Talk. You can meet our staff, you can see our facilities, and yeah, for more information, check out our website, spark.mcmaster.ca. Thanks so much again, Jeremy.